All right, so 6.3, number 10, properties of trig functions. So what were we doing? Find the exact value of each of the remaining trig functions of theta. And what's the plan for today? We're going to finish 6.3 is the plan my notes say. Start 6.4 perhaps, finish 6.4 tomorrow. So the homework will be 6.3 due tomorrow, Tuesday. Due tomorrow, Tuesday. So did you guys get lots of math work done over the break? Was that your priority? I know, it's hard, huh? Well, my college kids didn't seem like they were doing any schoolwork either.
That's an assumption, Mr.
Yeah, it's probably fairly valid. All right. So my daughter cruised on back thinking, oh no, I'm way behind now. And maybe that's how you're feeling. All right. So cosine theta is negative 7/8. So they're giving me that, and they want me to find the sine. Find the exact... Oh, yeah. I'm with it now. Maybe it's all coming back. We draw the triangles kind of thing. Probably you're already there. Yeah, so they're giving me this, and I got to draw the triangle. Can you tell what quadrant that is saying between?
Third?
Yeah, third, yeah, because pi's right here, and 3 pi over 2 is there. Yeah, so it's saying third quadrant, totally third quadrant. Right there. There's theta in the third quadrant like that. Let me draw that a little bit better. Theta's in the third quadrant. Okay, so theta's in the third quadrant, and it says the cosine of theta is negative 7/8. So now remember, so this is theta, this is the hypotenuse, so this side's the adjacent, because it's next, adjacent means next to it, right? And this is the opposite. Remember how that works? On that, remember all that trig stuff? And so you draw the triangle theta in the third quadrant, because they said it's between pi and 3 pi over 2. You always put the angle to the x-axis. In other words, you don't put the angle here between the line and the y-axis. Why? Well, because it's called a reference angle, and it's because 0 degrees starts right here at the x-axis. So therefore, we want to make all of our angles connecting to the x-axis, not the y. That's called a reference angle. That way, all the trig functions, sine, cosine, tangent, will all be the same that way. I don't know if you remember some of that from your trig class. So that's called a reference angle. It means with reference to the x-axis, referring to the x-axis. So in other words, what I'm saying is, if you did the same triangle in the first quadrant, same angle to the x-axis, which would be from 0 then, you'd get all the same trig functions if you drew the same size triangle. Sine, cosine, tangent, all of them would be exactly the same. So that's what we call a reference angle. We mean however far it is from the x-axis. That's the same thing as if you just put it in the first quadrant at that. Okay, so now cosine. Remember the SOHCAHTOA? SOHCAHTOA. How you find sine, cosine, and tangent kind of stuff. Oh, did everybody get a unit circle? Let me pass those out. So we got sine. So let me get a little room here, and I'll do some other ones. Okay, so we got sine, and they gave us cosine. So I'll go on to tangent. What's tangent? Well, right here, opposite over adjacent, right? So SOHCAHTOA, opposite. So opposite over adjacent. So root 15 over 7. Now, is it positive or negative? Well, all students take. So in our quadrant, tangent's positive. So he's positive. So now we have sine, cosine, and tangent. Now we can get the other 3 by flip it, right? The other 3 are just upside down of these 3. So here we go. So we have the sine here. The upside down of sine is cosecant. That would be negative 8 over root 15. Just flip that thing. Like that, I just took sine and I flipped it. I put the 8 on the top and the root 15 on the bottom. Let me move that up a little bit. We have a little more room. Like that, negative 8 over root 15. And how do we get rid of that root from the bottom? Multiply top and bottom by root 15 minus 8 root 15 over root 15, plane 15. Good for cosecant, just the upside down. Same sign and everything, just flip it upside down. And then, bless you. And then the upside down for cosine, well, here, let me do tangent. Cotan be upside down here, so that'd be 7 over root 15. Again, can't have the root in the bottom. Multiply top and bottom by root 15. Say cotan is 7 root 15 over plane 15. So got the cotan, got the cosecant, and the last one is flipping the cosine, huh? So I take the cosine, which they gave me right here, and the upside down of him is secant. So just flip him, put the 8 on the top, 7 on the bottom. There we go. Got all 6 trig functions. Luis.
I don't know if it's a 30, 60, 90 or a 45, 45 time.
Yeah, we don't. This one is actually neither. Yeah, yeah, I know because of the values it's neither. But yeah, we don't know that, nor need to know that on this one. Yeah, we will on some of the other ones, and I'll show you. Or maybe we've done some of those already, haven't we? Yeah. So this one, I never actually even found out what the angle is. Like you're saying, we don't know whether it's 30, 60, 45. In fact, it's none of those. I know because it's not coming out those memorized values, root 3 over 2, a half, or root 2 over 2. It's not coming out those values. It's root 15 and weird stuff. So it's not 30, 60, or 45. Yeah, and we don't need to, because all we do is we just make the truth of cosine minus 7/8 minus 7/8, and then find the other side by Pythagorean, and we find all the trig functions that way without ever knowing exactly what the angle is. It's kind of interesting, huh? It's kind of weird. We can find all the trig functions without ever knowing what the angle really is. We just find it by putting the cosine truth in the 7/8 truth in the third quadrant triangle, finding the third side by Pythagorean, and then we can get all the trig functions, and we never found the angle. All right, probably did some of it in your trig days. Okay, let's try this one. Really, really valuable for sure. I think there'll even be 2 of these on the final, because we have it in this section and another section, I think. Or maybe we already had it, I can't remember. Anyway, I think there's 2 on the final. It's really, really important. It'll be important in calculus. You'll use these little triangle things. So give that one a try. Let me jump in and have this. They're coming at us a little different on this one, aren't they? So first off, I would take that secant fact. Secant theta equals 3. And secant is upside down of which one? Cosine. You remember that? You could put that totally right on your 3 by 5. Sine upside down is cosecant. Cosecant. You know, cosine upside down is secant, and tangent upside down is cotan. Those are the reciprocals. So anyway, yeah, I would put those on your 3 by 5 card if you're not 100% clear. So secant, yeah, this is 1 over cosine. Or we could just say, look, if secant is 3, then cosine is 1/3. True enough? Good so far? So really, I always like to just deal with sine and cosine, really. If they give me some weird secant fact or whatever, I just convert it to sine or cosine or tangent right away. So starting with this, cosine's 1/3. Okay, so I'm going to draw a triangle in one of the 4 quadrants that fits this cosine fact and, same kind of thing. But which quadrant am I in? You figure it out by looking at the sign of the, what's the sign? That's cotangent, greater than 0 means positive, huh? So they're saying, hey, cosine that's certainly positive, cosine's positive, and cotangent is also positive. In which quadrant, remember, it's all students take calculus. They're all positive here. Now, tangent and his upside down cotan are possible. Maybe we're in the third. Maybe we're in the third, but no, we're not. Because in the third, cosine would be negative, yet he's positive. So yes, first quadrant. Does everybody see that? Got to be the first. The only other possibility was the third, where tangent is positive, but cosine, the other four are negative. So cosine would be negative, and we're told cosine is positive. Or you might think, oh, cosine's positive, you're in the fourth. Okay, yeah, cosine's positive in the fourth, and so is his upside down secant. But the other four are negative, which would include tangent. Tangent would be negative if you're in the fourth, and we're told tangent and cotangent are positive. So we're in the first. We're in the first quadrant. That's what they're telling us. That's all we can just throw away this fact now. All they're really giving us that for is to decide which quadrant. First quadrant. First quadrant. Okay, so we're in the first quadrant by the All Students Take Calculus. So use that often to help you out. So there we are. So remember, put your angle to the x. I see a lot of students mess up. They put it right here. That'll change your values. Don't put the angle to the y-axis. It's really important to put your angle to the x-axis, or it'll switch your x and your y and mess you up. So there you go. Now put in the truth there, cosine, SOHCAHTOA, all that. Use Pythagorean, find the third side. Take a second. So cosine is 1/3. Now, SOHCAHTOA. Cosine is adjacent over hypotenuse. That means this is adjacent and hypotenuse, right? So this is the angle theta. This is the hypotenuse because it's, across from an angle. This is adjacent and this is opposite. You good with that? From theta's perspective, this is the side next to theta. That's what adjacent means, next to you, right? Your neighbor lives next to you, adjacent to you. This is the hypotenuse, because it's across from the right angle. This is the opposite, okay? So adjacent over hypotenuse. So this is 1, this is 3. Good there so far? So now we find the other side, call it y or whatever you want, with the Pythagorean theorem. So 1 squared plus y squared equals 3 squared. 1 plus y squared is 9, subtract 1. Y squared is 8. Y squared is 8. So that means y is the root of 8. Y is 2 root 2. You okay with that simplifying root 8? Just do the pairs there, right? Right, root of 8. It's 2 times 4, 2 times 2. 2 2's in, sends 1 2 out. The other 2's left in. Okay, so we got y. This side here, the opposite side, is 2 root 2. And now we can get all the trig functions, can't we? Once you have the whole triangle, you can get all the trig functions. So we'll say, okay, what do they want? So we got cosine. Let's get sine. Sine, as you know, right here is opposite over hypotenuse. So opposite over hypotenuse, so 2 root 2 over 3. And tangent of theta is opposite over adjacent. So it's opposite over adjacent, 2 root 2 over 1, so that's just 2 root 2. So I got sine, tangent. They've already given me secant. I found cosine. Then you just got to find the other two. Just flip them. Is that okay? Are we all good on that? Anything I can answer for you on that? Yeah.
So
Cyrus.
you found cosine by doing what secant is. Secant's 3, so cosine would be 1 over 3.
Right, flipped it. Correct.
Okay. So then you took that and you made the hypotenuse to be adjacent?
Yeah, because cosine from SOHCAHTOA, cosine is adjacent over hypotenuse. So I knew that 1 must have been the adjacent and that 3 must have been the hypotenuse. So I made a triangle, and I made adjacent 1, hypotenuse 3, and then I found the other side by Pythagorean. All right, good? Other questions I can answer? All's well? All right. Okay. Cosecant of minus 45. Yeah, even odd. I don't know if you remember that. I'm assuming probably not. I didn't after trig. Remember all those little tiny little things? Let me give them to you. So basically, cosine and his upside down secant, they just kind of go together with their reciprocal function, their upside down function, are both even. Now, what does that mean, even? That means plug in, they're even functions. You plug in negative x, and the negative vanishes. Well, cancels, whatever. Sounds dramatic. It vanishes. The other four, sine and his upside down cosecant, tangent and his upside down cotan, those are all odd functions. And what that means is you plug in. Oh, we've done even and odd, huh? You might remember what even and odd are. No? Yeah, right. That final exam's coming. Plug in, so odd functions mean if you plug in a negative, plug in, well, I shouldn't say negative x. Plug in negative. Just plug in negative. And the negative vanishes for even. If you plug in negative to odd, negative goes to the front. It doesn't vanish for odd, but it goes to the front. Okay, so what am I talking about? So plugging into cosecant. See how they're plugging a negative into cosecant? So what? And cosecant is odd. So when you plug in a negative, what happens? That negative goes to the front. So that negative just comes right out here. Negative cosecant. Does that make sense? It just allows me to move that negative to the front. If this was cosine or secant, I would just ignore that negative completely, just erase it. Do you all see? It's about what you can do with negative signs and what you can't do. So for odd functions, pull to the front. Luis?
Do the graphs, when we graph them, does the shape matter? Like an even, does it look like a parabola?
Yeah, even means y-axis symmetry. Same, both sides of the y-axis is what even means. Odd means origin symmetry, 2 quadrants away. That's a little more confusing.
So there's only origin and x-axis symmetry, or there's also y-axis symmetry?
There is y-axis symmetry, but it's not for even or odd functions.
Okay.
Oh, no, I'm sorry. Y-axis symmetry is an even function.
It's an even.
X-axis symmetry is not for even or odd functions.
Okay.
Yeah. Okay. So cosine. Now, how do we do cosine of 45 degrees? Cosecant, I mean. Cosecant of 45 degrees. We.
Let Mr. Aaron do it.
Okay. So what were we doing? What was the question? Oh, cosecant 45. Now, yeah, cosecant is upside down as sine. So we'll kind of scribble in there. Let's change that to 1 over the sine of 45 degrees. Is everybody good so far? Because cosecant is upside down of sine. So it's negative 1 over the sine of 45. Let's go find the sine of 45. Where's 45? 45 is right here.
2 over 2.
Yeah, remember the cosine is the x-coordinate and the sine is the y. That's the most important thing to remember about the unit circle. X values are always cosine. Y values are always sine. Now, they're both the same. In this case, it makes no difference, but other times it'll matter. So the sine is root 2 over 2 for 45 degrees. So we go root 2 over 2. Now, what do we do with a fraction on the bottom of a fraction? Flip it up. Negative 2 over root 2 like that. And then multiply top and bottom by root 2. And get negative 2 root 2. Root 2, plane 2. 2's cancel. Negative root 2. You all good with that?
That would be in the tangent, the third quadrant?
No.
Would negative cosecant 45 degrees be in the third quadrant?
Okay, well, okay, so negative 45, why I'm hesitating is because we changed the quadrant. We changed it from negative 45, which would actually be here, down 45. Right, that was the original. Yeah, here's the other way you could, maybe I should answer this way. We could have just done none of this even odd stuff. If you want, just say, hey, forget about the even odd stuff. I'm just going to directly answer, what is the cosecant of negative 45 degrees? Well, it's 1 over the sine of negative. Just leave that negative in there. Who cares about even, odd, move the negative, whatever. I'll just do negative 45 degrees. That's fine if you know how to find negative 45. Where is negative 45? Well, it just means start at 0, go down 45 instead of up 45, huh? So go down, it's right there, it's 315. It's this one. And so it hits right here. And what's the, remember, sine is the, no, it's backwards. Cosine is first, sine is second. So the sine is negative root 2 over 2. That'll work fine.
How come you went down 45 and not across?
Down, no. I went down because it's negative. Now I'm doing the negative 45 degrees.
So wouldn't the other side also be the negative counterpart?
What other side?
Directly across.
We
Directly
need
across.
x-wise. It means like on the left side.
Over here?
No, you see how you have 45 right there? Point at it.
Okay, so an angle is an amount of opening between two lines.
You have it right there. Why don't you just go across? And wouldn't that be the opposite?
So I'm going down 45.
Oh, 5 pi over 4 in that area? Yeah.
You mean over here?
No. Down.
Down?
It's there.
Down here?
I'm not that sick. You see right there, 225? The degree?
He means across the circle.
220. Where's 220? Oh, 220 here?
Yeah, that's the same sign as the answer.
Oh, it is?
Yeah, isn't that just the opposite of that?
Is the circle.
Well, all the values are going to be repeated at least twice around the circle. But that doesn't mean I can just pretend it's that different angle. I mean, it's true that they are repeated in other places, but negative 45 is not 225.
But
They have the same sign, but they're not the same place. Am I answering your question? Just because they happen to have the same sign value, coincidentally, for this case, it's just by luck, they have the same sign value. But that doesn't mean you can go, like, why would you want to go to 225?
no, I went across from it. I went across with the angle. Because
Oh,
it would
like
be the
straight
opposite.
across, like
Yeah.
that? Oh, yeah, in that sense that they're both down the same amount? Yeah, that's true. They're both down the same amount. Come talk to me later if you want to talk more about that. So negative root 2 over 2. So coming on back, so negative root 2. You could just do it that way. You could just directly do negative 45 degrees on that. Either way. We good? All right. Yeah, so do it either way you want. You could just, they want cosine and negative 90. You could just go to that unit circle you have in front of you, right? Go to that unit circle and just find negative 90 and just do it that way. Or you could remember the even odd thing I just told you and do something with that negative sign. You could either get rid of that negative sign or move that negative sign to the front, and then you wouldn't have to deal with a negative angle. But it's not the end of the world to do a negative angle. You could just handle the negative angle. Whatever you prefer. So, let me see, I'll go over here. Maybe I'll just do a fresh one. Okay, so negative 90. So I'm just going to do negative 90. Here's 0. So negative 90 is straight down, huh? Is that good? So it's this dot right here. Remember, cosine is the x, sine is the y. So cosine be 0 on that. So you can just do that if you want. Now, the even odd thing, what they mean is you could just totally erase that negative, huh? Because cosine, go back here, cosine is even, which means negative vanishes. So you could just do that and say, look, it's just the cosine of regular 90. The negative vanishes. And that's true. Regular 90, see how the cosine is still the same thing? Cosine is still 0. Either way, it's 0. Good? Easy? All right, I'll see. Okay, so secant. Now, what is secant?
I'm going to cosine 1 over cosine.
Yeah, good. 1 over cosine. And like I said, now what can you do with that negative in a cosine? Bye-bye. He's even. So you can just ignore him completely, right? If it was sine, it would come to the front. Because that's an odd function. For even functions like cosine, just ignore the negative. So just cosine pi over 6. So just go to the 1 over cosine pi over 6. So go to the unit circle. Find pi over 6 right here.
Root 3 over 2.
Right, cosine's the first one, sine second, so root 3 over 2. So we go, okay, it's 1 over root 3 over 2. What do we do with the fraction on the bottom? Flip it up, right? Flip it up. So it's 2 over root 3. Can't have a root on the bottom, so we multiply top and bottom by root 3. So 2 root 3 over regular 3. And there we go. Good? Questions? Easy for you, right? Can you tell me the answer? Who's got it? 1. Right? Because they're upside down.
Oh, yeah.
Right? I don't know what sine of 37. I have no idea, but I don't need to. Cosecant is 1 over sine, isn't it? So whatever it is, they cancel and it's 1. They're just making sure you know that property. Good. See, we've been through all the hard stuff now. Trig's pretty easy for most people because you've already had it this time. See how they changed the angle? Well, it's on the screen here. There we go. See how they changed the angle? They didn't do 425 in both cases, or that would be 1. So cosine 425, secant. So secant is 1 over. So this is 1 over cosine, right? So now, can I cancel those?
Yes. Because if
Why?
you
Why, Seema?
subtract- Because if you subtract, it's 63.
Beautiful. Exactly. 425 is more than a full 360. So let's subtract 360 and you get, what a surprise.
Plus 2.
That's the same as
So
65.
that would be 1.
So that's 1.
That's how you lied to me. Because in the beginning you said it wasn't 1.
Well, I said it wasn't 1 for that reason. At least that's what I meant. We good on that?
The formulas would be like cosine parentheses 65 plus 2 pi, right?
Right, but I can just get rid of that 2 pi. Because that's just an extra rotate. That's just an extra full circle. So in other words, let me show you on the unit circle. Where's the unit circle? There it is.
It's on the same spot, just for 60.
Exactly. Bless you.
Plus
Where are we at? 65?
Plus 2.
So wherever 65 is, probably about right here, a little past 60, you know. That's 65, right? Well, if you from here to here is 65. Well, if you go another full 360 around, you add 360 more, this is 425 also. It's the same exact spot. So it's going to have the same sine and cosine in all the trig functions. Yeah. There it is. So you know all that. So 425 just becomes 65, and cosine 65 over cosine 65 is 1. But it's not 1. No, it is 1. We good?
That's 1, right?
What's the other really common number that it might be?
0.
There it is. I won't lie to you this
Oh, yeah,
time.
because they're not the same thing. They can't add because they're all different.
Yeah, do you see it's going to be 0? I mean, actually, honestly, I haven't seen it yet. I'm just kind of guessing. I bet it's going to be 0.
It's like oil and water. Yeah. They don't mix.
Well, these will mix and be 0. Okay, I'm guessing it's 0. Let's see it. What can we do with a negative in
Nothing.
a sign?
Right?
Add 360. No.
You could, or you could just yank it to the front. Remember what we learned just a minute ago about odd functions? Yeah, you could add 360. That's okay, too. You could do the add 360 thing. Yeah, actually, that'd probably be better, huh? Because the other one's 242. Yeah, let's do what Seema wants to. We always do what Seema says. All right. So yeah, we'll take the negative 62 and just add 360. I'll say, hey, let me find that same location by adding 360. What? Oh, no, that's not going to work too well. Seema,
That's
what are you
298.
thinking? Oh, they're being more tricky. It is 0. They're being much more tricky on this one.
I could just guess that on a
Can we
test
move
every
the
time.
negative outside to the sign and then add 62 plus 2 pi? Or 260. And it'll give us 422.
What do you want to do, Luis?
Put the negative in front of the sign
Right.
and then add 360 to 62 plus 2 pi. Wouldn't that give us 422?
Mm-hmm.
And then we would tangent right sin theta cosine theta.
Yeah, okay, your way's got some good thoughts to it. I like it. Let's do it. So yes, let's just yank the negative to the front. So negative sine, see, all these ways will work. You just got to keep fiddling with this thing. It's going to be 0. I would bet a lot on it. So we get there. So far, so good. I just yank that negative to the front. Okay, and then 422. Well, yeah, let's do what Luis says. Or let's just subtract 360 from this one. How about? Either way, doesn't matter. Subtract 360 from that one, and that leaves. Isn't that 62? Yeah. 62. So what does that mean? It means we have minus the sine of 62 over the cosine of 62 plus the tangent of 242. Good so far? Everybody see what we've done? I just yanked the negative to the front because sine's an odd function. And then subtracted 360 because this was more than a full rotation. And this is now tangent, isn't it? Remember sine over cosine is tangent? Remember that? So that's minus tangent of 62 plus tangent 242. Now, at this point, it's a little tricky. Like, can we just cancel those and say it's 0? Yeah.
Oh yeah, because it's 360 ahead, right?
Well, it's more than, it's not 360 ahead, right? Because that'd be more than 360. It's 180 ahead. Tangent's period is 180. Do you remember that? So that's the other fact you need to remember. Let me write that
Or
down.
you could just add them together and then flip it that way.
Just do what?
Couldn't you just add them together and then divide?
By 2.
Because if you add 242 minus 62, you get 180, and then you can find tan that way.
You can't add angles.
You can't add the angles that way. And tan of 180, no, that wouldn't be right. Tan and cotan. Yeah, we can't just add two angles of two trig functions like that. Tan and cotan have a period, a cycle, that is 180, whereas sine and cosine and their reciprocals, cosecant and secant, have a period, a cycle, a repeating pattern of 360. Yeah, do you remember that? I think we mentioned it the other day. And you never forget anything we say in here, right? So, so is that good to there so far? Tan and cotan, the period is 180, meaning tan and cotan repeat values every 180 degrees. Tan and cotan do every 180 degrees. Whereas, so what that means is instead of like adding or subtracting 360, like I normally do to find same values, one full rotation around, I can just go half a rotation around and tangent starts repeating. Just add or subtract 180. So I could say, look, I've got this minus tangent 62 plus tangent 242. I bet this 242, if I subtract 180, it's the same as 62. So for tan and cotan, you're allowed to add or subtract 180 whenever you want. You get the same values. You haven't changed anything. So this becomes minus tan 62 plus tan 62. So sure enough, as we knew all along, it's a big 0. Multiple choice test, you just guess 0 from the beginning, huh?
Are you going to make it that easy? Man, you're a real one, Mr.
We're gonna get a 0.
And 2 zeros and 1 in the front, right?
We good? Questions on all that? That's a little bit of trickery there. All right.
Did you finish 6.3 with the other classes?
I don't think so. No. Nope. All right. So, any guesses as to the answer?
0.
All right, let me give you a minute.
4 plus 4 plus 4.
4 plus 4 plus.
So it'd just be 16 plus 3 pi? Or 12 plus 3 pi?
What's cotangent of theta?
4.
So that's 4. What did we just say about tan and cotan? About how they repeat every 180. What's 180 in radians? Pi. So if you add pi to the angle or subtract pi, or any multiple of pi, every pi, or 2 pi, or 3 pi, or 4 pi, or 5 pi, every extra pi, you're just back where you started. So what's the cotan of adding a pi going to be? Same thing.
So 16.
And what's the cotan of adding 2 pi going to be? Back to 4. 12 it is, right? That makes sense? They're just saying, do you know that when you add pi or a bunch of pi's, you're just back where you started. Nothing's changed. For tan or cotan, you can add 180. Their cycle, their period, is pi or 180. If you add pi or add 180, nothing changes in the values. They repeat themselves every pi or 180 degrees. That good? They're just testing that you know that. All right. Okay, why is that the case? So they're saying, when is cotan not defined? Well, to answer that, you got to remember that cotan is cosine over sine. Remember, tangent is sine over cosine, and then cotangent is upside down, right? So it'd just be cosine over sine. Good so far? Cosine over sine. And so basically, when is a fraction not defined? What can make a fraction not defined?
when it's a whole number, right?
Bottom is in 0, huh? So if the denom equals 0, then it's undefined or not defined, however you want to say
So a
that.
whole number?
What's that?
So a whole number?
We'll get to that. So bottom 0, right? So that means sine theta 0. If the denominator is 0, sine theta is 0, then it's not defined. Okay, so what angles theta are, where is the sine of theta 0? Let's go to the unit circle, our good friend, the unit circle. So where is sine 0? Remember, cosine is the x, sine is the y. Sine is 0 at 0, and where else? 180, pi. Sine is 0 at pi. So 0 and pi, and then any multiples thereof. Makes sense? All the multiples of pi. In other words, when theta is 0, or pi, or 2 pi, or 3 pi, or on you go. In other words, n times pi. Anything times pi. Like it? That's all I answered there. Is multiples of pi, or 180. Not odd multiples, not just 1, 3, 5, not even, not just 2, 4, 6. All the multiples of 180. That includes 0, by the way, because if n is 0, 0 pi is 0. Right? Okay. Do you guys know the domain and the range? Oh, look at the time. This is not on the test. I'll just tell you that straight. I'm not going to ask you the range of the... I might ask you the range of the cosine, but I won't ask you like the range of the secant. It's a little weird. So, yeah, it's really weird.
Hypotenuse over...
Yeah. We don't have time for me to do much. Okay, secant. See, even my not doing much is going to take a little bit. Secant's 1 over cosine, right? Do you remember the cosine graph?
No. Yeah.
Yeah, up and down, up and down, up and down, right? Sine and cosine basically do that. Cosine starts high, so boom, like that forever, like that. Okay, so what? Well, how high does it go? What's the highest the cosine goes? 1 and -1, right? Okay, now secant is upside down to that. What if you take that graph and flip it flip the values upside down? Not the graph. If you turn the graph upside down, it wouldn't look like much different. But if you flip the values, what do I mean the values? Like how high is this right here? About a half. It's about a height of this, because this is height of 0, this is height of 1. It's about height of half. Take a half and flip it, what do you get?
2, 1.
2 over, it's up here. So secant, so basically secant, and if you take 1 and you flip it, what's the flip of 1?
1.
Still 1, it's right there. So notice what it is. And now right here, it's at 0. When you take 0 and you flip it, what do you get?
0.
You 0 and flip it, you get 1 over 0, which is
0.
undefined, as we just said. 0 on the bottom. So these are actually vertical asymptotes, and the graph goes zoop, zoop. This is what secant does. It shoots up like that. It's a long story, which we don't have time for. So basically it goes from a height of 1 on up, and from a height of -1 on down.
So it's C?
Greater than or equal to 1, yeah. Well, that's it. I hope those last couple aren't